Okay, this time we want to find the limit of sine x over x numerically. The way we want to do it is by thinking of values that get closer and closer to 0. So I want to start with negative 0.7. Oh. Don't ask me why I chose that, because that's what I have here. But it's kind of close to 0, right? If I plug in the negative 0.7 into sine x over x, I will be getting the value 0.92031. Now if I plug in negative 0.2, or negative 0.2, then the value I'm going to get will be 0.993347. And if I plug in negative 0.05, the value I'll get will be 0.999583. And then if I plug in 0, it will be undefined. On the right side, if I plugged in 0.01, the value will be 0.99983, so 4 nines. And then if I put 0.03, I'll be getting 0.99985. And if I put 0.3 into this function sine, if I evaluated sine of 0.3 over divided by 0.3, if I did that, then the value I would get will be 0.98506. I wanted to save time by not punching this into the calculator, but on the exam, when you are given such a question, and it comes up in the calculator portion, you're supposed to come up with numbers that get closer and closer to 0, like this, and you have to actually punch in these numbers into the function you have, and you have to calculate them. Okay? So you have to calculate them and list all the values. Now, look at the left limit. Where are these values getting closer and closer to? 1. It's getting closer. It's increasing towards 1, right? Look at the right limit. It's also increasing towards 1, right? So it looks like that the left limit is 1, right limit is 1. Do they agree? Yes. Therefore, what is the limit? That is what the value is. Now, I want to make a comment why we like radians why we like radians in math, in calculus. The reason that we like radians better is if you did the same thing with a calculator, in degree mode, you're not going to get this 1. You're going to get a totally different value. In fact, I think the value will be, so note, warning, if the calculator is in degree mode, you will get limit x going to 0 of sine of x over x. So actually, because you're in degree mode, you're really dealing with this. If your x is treated as degrees, the value of this limit will be pi over 180. It will get to this value. And you wouldn't even recognize it's this value because it's, you get, in actuality, 3.1415, this pi divided by 180 gives you a number that's so strange you wouldn't recognize what the number is. Okay? So you will completely miss this question if your calculator is in degree mode. Okay? And for the future context, we will later use these limits to figure out something called derivatives of sines and cosines. And if you have derivatives of sines and cosines, and you really want everything in radian mode, because this is very much these two results are very much related to derivatives, and just having the fact that sine x over x gives you 1 in radian mode makes the derivatives of sine and cosine very easy. It makes sine derivative of sine is cosine, derivative of cosine is negative sine. That's what you're going to learn later in this class. Whereas, because of this property, if you differentiate sine x degrees, you're going to get pi over 180 cosine x degrees. So you get all these very messy numbers appearing once you use degrees. Okay? That's why we like our radians so much when it comes to calculus. We're not trying to make things hard, we're trying to make things easy by using radians.